Okay, now all 22 subscribers are tuned in, ready for this lesson. That was funny. F of x is equal to negative 2x squared plus 3x minus 1. Alright, yesterday we did 5 things to these equations. We graphed them, we found the vertex, we found the axis of symmetry, we discussed the domain, and we discussed the range. Okay, and we hit those 5 things. This lesson starts off telling me to do that again, but like I just said, I don't think we need to beat that dead horse any more than we already have. I'm just going to review us all we're finding the vertex, and then we'll roll, okay, unless we like do horrible here. All right, vertex, what form am I in? Does it tell me the vertex, or do I need an equation to find it? I need an equation because I'm in standard form. Very good. X is equal to, right over here on the side, you wrote it yesterday, negative b divided by 2a. Okay, now you can write that negative b a couple of different ways. You can do it like you do in the quadratic formula and just take the opposite sign of your b. Or you can write that negative sign out there in front every time and just keep the b like it is. It'll work either way, it doesn't matter. I'm going to write this as x equals negative for my negative sign. My b is 3. My a is negative 2. So that's how we would start off here. Now this is a mean problem to begin with, because what kind of number am I going to get when I simplify that there? Is it going to be an integer? Ooh, that was a big math word. What does integer mean?
It's going to be a fraction.
Very good, which is not an integer. An integer is positive or negative whole number. Negative over negative turns out to a positive, so that's just going to be 3/4. Right? So looking for my vertex now, I know it's going to be 3/4. Comma something. I got to find that something. So what do we do to find the something? The boys' name, we plug that back in for the x's, which makes some fraction work for you, but pull your boots up and get after it. It doesn't matter. Negative 2 times 3/4 squared plus 3 times 3/4 minus 1. All right, let's check out our fraction work. That's squared, 3/4 squared. Remember when you square a fraction? You got to square numerator and denominator. So this would be 9/16. Then you got to multiply by negative 2. Negative 2 times 9/16 would be negative 18/16, which is negative 9/8. Okay. 3 times 3/4 would be 9/8. And then I got a minus 1. Something that's not right. 9/4. 3 times 3/4 is 9/4. Should be a 4 down there. Alright, now, you could, and this doesn't bother me for y'all, because I know y'all are good at typing all that in your calculator. If I want to do those fractions without a calculator, though, like I'm fixing to do, my common denominator is going to be 8. So that one's going to stay as a negative 9/8. This one I wanted to multiply by 2 to make it an 8, so I'm going to have 18/8. And then 1 would be 8/8. Okay, so negative 9 plus 18 is 9. And then 9 minus 8 is 1. So you would get 1/8 on that. So my final vertex, I've started the 3/4 up there. Let me scroll a little bit there. Whoop, whoop, whoop. Woo! Magic. 3/4, 1/8. Is that what y'all got on your calculator?
Yes.
Good, 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 and good. Whew! What are you doing, Cal? Nothing. Do something. Come on. She said nothing. Alright, we're going to do one of these discriminant problems. We did one of these last unit, but I want to talk another one right quick. Let's say I had f of x is equal to negative 3x squared minus x plus 2. Alright, directions on this say find the discriminant and use it to determine the number of x-intercepts that the graph has. Okay, remember when you're solving quadratics, you're actually finding the places where they cross the x-axis. Okay? And we talked last unit about the discriminant will tell us exactly how many and what kind of solutions that we're going to have. The discriminant is the part of the quadratic formula that is only underneath the radical. So it's just the b squared minus 4ac. and we've written this last unit, you might need to write it again. If my discriminant is a positive number, bigger than 0, that means there's going to be 2 real solutions, like that little graph I drew there to the right. It crosses 2 times. If my discriminant is less than 0, meaning a negative answer, there are going to be 2 non-real, which means my graph is never going to cross the x-axis. If my discriminant is exactly 0, there's just going to be 1 real solution. That would mean it just touches 1 time, like it just sits on it like that. Okay? So for that problem that we wrote there, b squared, what's the b in that problem up at the top?
-1.
Negative 1 squared would be 1, so I'd have 1 minus 4. What's my a? Negative 3 times c, which is 2. Alright, so we're looking there at 1 minus negative 24, right? Which is 1 minus a negative, same as adding, so I got 25 for my discriminant. 25, is that bigger than 0, less than 0, or equal to 0? Bigger, so this problem has 2 real solutions. Winner, winner, chicken dinner. Could I figure that out if I just worked the whole problem? Yeah, they wouldn't have had eyes in them, and there would have been 2 of them, so they'd have been 2 real. Alright, this next problem, I'm going to get into just a couple of word problems here. This is my favorite one that we've had in a while. We got what we need off that one? Alright, it says here that a farmer has 120 foot of fencing. He wants to put a fence around a rectangular field next to a building. Okay, so what you got to envision here, this is hard for some people to do, there's the rectangular field, but his fence is only going to go around 3 sides of it. Okay, because right here, whoops, come on, right here is the barn. He's putting the fence up against the barn or the building and using that as one of the walls. So he doesn't have to put fence there. Does that make sense?
Yeah.
He only has to put fence where the yellow is, okay? Where his house or barn or whatever is secure, they can't get under, it's going to be a fence there. All right, so we got 120 foot of fence. We're asked to find out the maximum area he can have and what would the length and width be with that area. Now you could do this using trial or error, but since we're doing quadratics here, I'm going to do it that way. Let's say here that the length of old Farmer Fred's fence, if that's an X, this one also has to be an X. Duh, right? How much total fence does he have? I told you 120 feet. So what I've got so far on my widths, I have an X plus an X plus a length has to equal the 250 feet. Now a normal rectangle would have 2 lengths, but we've got the barn there. We don't got to mess with that. Okay, so X and X, that gives me 2 X's plus a length is equal to 250 feet. What would I do on that to get the L all by itself?
Divide by 2.
Close. To get the L all by itself, that cursor,
2x.
subtract that 2x. So the length would have to be 250 minus 2x. So this bottom part of my field down here would be 250 minus 2x. Now to find the area we've just enclosed there, it's still a rectangle, so you're still doing length times width. So that would be, do you see your length and your width there? Let me change the color again. You got, come on, color changer. X times 250 minus 2x, there's your length times your width, right? So our area, x times 250 minus 2x, distribute 250x out of kid custom, minus 2x squared. Okay, there's our parabola that we're trying to solve. Now the question, it's craziness to me and to some people to think, here we've got a rectangle and we're trying to figure out the area of the farmer's fencing and the teacher's talking about a parabola. Kablooey, that blows my mind too. But the parabola is the relationship between the amount of fence and the area. It's not just the dimensions of the rectangle. If I'm trying to find, I should have already drawn this. If I'm trying to find the maximum area he can have, can you look at this and know that that parabola opens down? Can you look here and know that it's a parabola, first off because it's squared, and then it's going to open down like the one I just drew. What shows me that that parabola is going to open down?
Negative.
Very good, the negative a. It's flip-flopped, but that's still my a because it's squared. So the negative a tells me it's going to open down. So the maximum on this parabola, what's that called where it hits its maximum that we just found and we learned yesterday?
Vertex.
The vertex. So if I can find the vertex of that, that's going to tell me what his maximum dimensions can be. We luckily have an equation to help us find the vertex. So here we got a rectangular field with farmer and his fence, and we're making it into a quadratic equation. So my b is 250, negative 250 divided by 2. My a is negative 2. Negative by negative is positive. What's 250 divided by 4?
75. Negative.
It'll be a positive because negative over my negative. I don't think it's 75. It might be. It might be.
2.5.
2.5?
62.
62.5. Okay, so what does that represent on our drawing?
X.
Which would be?
That.
So 62.5 feet of fence is going to go right there.
Mm-hmm.
Which means 62.5 feet of fence is going to go right there.
Mm-hmm.
So how much is going to go here?
Would have to multiply?
Mm-hmm. Did you get it yet, Caleb?
$125?
120. Good, Rachel. Good, Caleb. So 125 feet of fence across there. So if we needed to tell him how far to measure out his stakes where he's going to put his string and line his fence, 62.5 feet by 125 feet. How do I find the area of that now? Right. You got length times width. So multiply those. Tell us what the area of his pasture or whatever that is.
7,812.5.
There you go. Was this right?
What?
Was this right? I don't know. I'm not remembering these numbers.
I'm pretty sure.
Okay. It's been a long day. What happens? I'm old.
Yeah, it was 62.
Okay. Good deal. I hate to have to rework the whole problem again.
No.
All right. That one, I said you could do trial and error, and you could. That one would be a little bit more difficult because sometimes we don't always think to try decimals and try fractions. We would be trying whole numbers for a while. We might could get close and then jump off there and do that. I know I worked at when I worked this first period, I did it with a different length of fence. So I didn't use 250. That's why we got a different answer that time. So at least I'm not crazy not thinking something. Alrighty. One more word problem, then we'll look at what's the major new thing real quick. This one's a fun one. Toy rocket is launched from the ground, so its distance in feet above ground after t seconds is given by s of t equals negative 16t squared plus 208t. Okay, so here you launch your rocket, goes up, comes down. Now, well, what do you know? It made a parabola. Everything that goes into the air is going to make a parabola. Even if you think it went straight up and came straight back down, at some point it had to rotate a little bit. So it might be super, super, super narrow, but it would still have some sort of parabolic shape. All right, so the question says find the maximum height. The whole point in these last two problems is just to make you see that when it's asking for maximum, it's asking for vertex. Same thing, this one wouldn't be called a maximum. What would that one be called that I just drew?
A minimum.
A minimum. Very good. So you got the difference in your maximums and minimums. All right, so to find how high this rocket's going to go, x equals negative b over 2a. Negative by negative is positive, so we got to figure out what 208 divided by 32 is.
6.5.
So 6.5. That would be the seconds. That would be how long it took it to reach its maximum. So we got to plug that back in now to figure out how high it was at 6.5. So we have negative 16 times 6.5 squared plus 208 times 6.5. How high did our rocket fly?
676.
It seems a lot for a toy rocket to me, but that is correct.
Okay.
That is correct. Good deal, Lucille. Alright, yesterday we did the normal up and down kind of parabolas. Today we got the sideways ones. Okay, we're going to talk to you a little bit about those. We wrote down standard form and vertex form. Same thing here. The difference, how you'll know it's a horizontal, I say sideways, that means horizontal, is instead of saying y equals, it says x equals. So we got x equals ay squared plus by plus c. That's standard form of a horizontal parabola. Okay? Now yesterday when we were in standard form, we had a formula to find our vertex that says x equals negative b over 2a. In this case, when it's horizontal, it'll be y equals negative b over 2a.
So
Okay.
same thing, the same, just X and Y?
Just flips the x and the y. So then when we get the vertex form, it's the same kind of deal that Rachel's talking about. It'll be x equals a times y minus k squared plus h. And our vertex on this will be the same thing with the opposite signs, but look where the k is. See, it's flipped them. So when you write it, it's still hk, but you're getting them from different places. They flip-flopped them. Alright, ready to try one of those, see what happens? We'll hit our 5 checkpoints on one and be good stuff. Got what we need there? A good piece of graph paper. It was amazing. Usually when I use this thing, the graph paper doesn't show up on my paper. This morning, on my tablet, this morning it did. It was the first time it had. But it didn't again now. It's back to just still being plain on here. I wonder what I did to make it show the graph paper this morning. It was awesome. Okay. We got x equals negative y squared plus 2y plus 5. We're going to do all 5 things that we did yesterday. We're going to find the vertex, the axis of symmetry, draw the graph, find the domain, and find the range. First thing I know, and this is stuff you're going to know, is that this is a horizontal parabola. That means it opens left or right because it says x equals. Other thing I know is that it's going to point, the arrows are going to point to the left. Okay, and you need to know this. Reason we know the arrows are going to point to the left is because our A is a negative. Okay, so if our A is negative, will look like this. It'll be a negative A. If our A is positive, will look like that when we're a horizontal one. Okay? Alright, so let's find our vertex and our axis of symmetry. We got y equals negative b over 2a. So that negative by negative is positive. 2 divided by 2 means my y is 1. Okay? This is your axis of symmetry. Yesterday our axis of symmetry was x equal, but we had a vertical parabola. Now my axis of symmetry is y equals because I've got a horizontal parabola. Okay, so there's my axis of symmetry. So I know my vertex is going to be something comma 1. Notice I put that in the y spot. It's different, flip-flop from yesterday. Plug that 1 in now and get your x. 1 squared is 1, make that negative, it'll be -1. Plus 2 times 1 is 2, plus 5, so that's 1 plus 5 is 6. So our vertex would be at 6, 1. I don't think I got 6 spaces, so I'm going to count on every one, blue and red. So this will be 1, 2, 3, 4, 5, 6, 1. Now we said that y equals 1 is our axis of symmetry. See, our axis of symmetry is laying horizontal this time because that's the way our parabola is going to go. Now I'm plugging in a y, something other than 1, because I already have a point at 1. So pick either 2 or 0 or something either above or below y equals 1. Okay, so we plug a 2 in. 2 squared is 4, make that negative, be -4. Right up here. 2 times 2 is 4, so that cancels. And then plus 5, so 5, 2 would be on our parabola. So 1, 2, 3, 4, 5, 1, 2. Okay, flip that, put it on the other side of the axis of symmetry. It's 1 away, so I go 1 away on the other side. Looky there, there's a horizontal parabola. Alright, so we've labeled vertex, we've labeled axis of symmetry, we've drawn a graph. Last things we have to talk about are the domain and the range, and this is different than yesterday's. Yesterday, domain was always negative infinity to infinity. Not the case here. This one, my domain, how far left is this going to keep going on my domain?
Forever.
Forever, so negative infinity. So it's starting off the same, but it's not going to keep going right forever. That's the x of my vertex where it stops. My vertex x was 6. So it's going to go from negative infinity to 6. This time, though, the range is going to be the one that's always forever, because this is going to keep going up forever, and this is going to keep going down forever. So on a horizontal one, it's your range that's negative infinity to infinity. Okay? All right? What do you think? Thumbs up from Mr. Zane Zane.
Good.
Okay, where we head next out of this is talking about symmetrical stuff, where things have symmetry at, when things are increasing and decreasing. That's when I talk about going uphill or downhill on your bike, that kind of thing. All right, everybody, feel like you find a vertex of any kind of parabola, horizontal or vertical? All right, that'll be a wrap. All right, no exit question today either.